Hello, we're going to look at the combined gas law. I tried to make another video of this, but it was a little too long for YouTube. So we're going to go through it again, and this one will be posted up for you. Okay, so the combined gas law looks at pressure, volume, and temperature. Okay, so P is pressure, volume, and temperature is T, okay, PV and T, in the beginning case and the end case. Okay, so we're comparing two different cases here. And so this is the initial conditions, final conditions. So pressure can be in kilopascals, millimeters of mercury, or atmospheres. There are also other units, but those are the most common ones. Volume, liters, milliliters, cubic decimeters, it's the same as a meter, or a liter rather, and then cubic meters. And temperature is in degrees Celsius or Kelvin. Now, whenever you have the temperature in a calculation, it must be in Kelvin. So how do we go from Celsius to Kelvin? We add 273. So degrees Celsius plus 273 is Kelvin. Kelvin is an absolute temperature scale. 0 degrees Kelvin is absolute zero. To go from Kelvin to Celsius, we subtract 273. But remember, always in Kelvin for calculations. So we're going to look at a couple of examples here. First one, okay, a gas is at 301 kilopascals, that's the pressure, in a 1.6 liter container at 13 degrees Celsius. It is transferred to a 1.8 liter container at 324 kilopascals. Find the new temperature in Celsius. So let's make a list of what we have. Okay, so the starting pressure was 301 kilopascals. The volume 1 is 1.6 liters. And temperature 1 is 13 degrees Celsius, but we have to add 273 to that. Okay, so 13 plus 273 is 286 Kelvin. Remember, always have it in Kelvin for a calculation. Pressure 2 is 324 kilopascals. Volume 2 is 1.8 liters. And we don't know the final temperature. So let's set this up. Okay, so here we have pressure 1, 301 kilopascals. Volume 1, 1.6 liters. Over a temperature of 286 Kelvin. Now, pressure 2 is 324 kilopascals. Volume 1 is 1.8 liters. And temperature 2 we don't know yet. So now let's solve this. So we're going to cross multiply. So 301 times 1.6 equals T2. So let's see what that is. Okay, so that's 481.6 T2. We're cross multiplying. Equals 286 times 324 times 1.8. So 286 times 324 times 1.8. Okay. So that's 166,795.2. So now let's solve for T2. We divide both sides by 481.6. Okay, so that means the temperature 2 is equal to 346.33. And that's in Kelvin. But we want it to be in Celsius. Okay, so we have to subtract 273. Going from Kelvin to Celsius, we subtract 273. Okay, and that comes out to be 73.33 degrees Celsius. And that's our answer. Okay, let's try one more. Here we have a gas started at 210 degrees Kelvin and 740 millimeters of mercury. That's the pressure. It is moved to 760 millimeters of mercury and 240 Kelvin at 1.2 atmospheres. Find the original pressure. Okay? So, pressure 1, we don't know. That's the original pressure. Volume 1, okay? Oh, I should say, I'm sorry, the volume is unchanged. Okay? So, the volume here is unchanged. We can just drop out the volume. Okay? So, original pressure we don't know. Starts at 210 Kelvin. Oops, I'm sorry. I messed up on this one. Okay. Tell you what, I'll make another video with this, but go with the first one. Sorry for the mess up. I have to change this. Rather than spending time getting it fixed here, I'll fix it up and put on another video. So look at the first example and start on the gas law problems. So I'll make another one early tomorrow. You can get started on this. Thank you.